Hello everyone, my name is Faye, and in these videos, we're going to learn about control structure reviews. Basically, it's your ALPRO1 reviews, okay? So, we're going to learn about loops, branching, but first, we need to learn about data types. I'm going to skip to here. The first data types that we need to learn is integers. Simply, it's a whole numbers and whole non-negative numbers. It's also including zeros, okay? So it cannot interpret fractions, decimal points. Integers is whole numbers, okay? So what is important here? You need to use the operation division, and mod. Okay, so maybe we already familiar with this operation, but let me teach you how we actually use this. Okay, so maybe we familiar with this operation in middle high school or high school when we take maybe 23 division 7. So you will get 3 on top here and 21 minus it, and you get 2. 3 is a division values, okay, div value. 2 is the modulus value, okay? That's what's important in integer data type. You can add it, you can minus it, but this is what makes it different. It has modulus operation. So if we jump to the next data types, it's real. It can represent fractions, decimal points for real data types. So what you use here is this symbol, okay? Division symbol, okay? And it doesn't have no modulus operation, okay? No modulus operation. That's what's important in real data types. So if you see here, it use this, but here you see it using div. And for disclaimer, first thing that this is work on pseudocode, okay? For Golang, it's different, but we learn about pseudocode here. And for the next data type is Boolean data types, okay? So what is important here? It only has two values, true and false. And what is important is the rights of the operation. In pseudocode, we use and, or, and not for negation. And the next thing, maybe you're familiar with these symbols. And for maybe some lecturers, if you use like this, small equals to, maybe you guys write it like this. Some lecturers doesn't approve this, so don't use this. Stick to this operation, okay? So that's for Boolean data types. And one important thing, here you see it using not for negation, this symbol, but here you see it using the symbols. Okay, so what is the right thing? Use this for not equals to. For not equals to. You not don't use this. Don't use this. Okay, this is not approved. This is the symbol you use. For negation only, you use not. Write it not. Okay, so this is the you need to read this table for what is come first and everything. And we're gonna jump to characters data types. Simply what is important here, everything you can solve on your keyboard, or maybe deeper, not only your keyboard, but universal keyboard. Everything there is characters, okay? And what is important here, use this, okay? Use this. One quote, okay? String, in other hand, using two quotes. This is string. Don't use this on characters, okay? And as you can see here, it noting ASCII table. So let me teach you guys how to read ASCII table. So our computers didn't recognize letters, okay? It doesn't recognize it. It recognizes it as a values of numerics values. Okay, so if we take example of V, because my name is start with V. If we take V, it will interpret as how we read this. So look at this. The column value is 6 and the rows values is 80. What we do with these two values, we add them, okay? We add them. We use plus operation as a numeric value. We will get V is equals to 80 my bad, and it equals to 86. Okay, so this is the numeric value that your computers understand. Use this, okay? That's how you read ASCII tables, okay? We're gonna move on to string data types. Last but not least, what is important here? Use this, okay? Don't use this. It's wrong in your pseudocodes, okay, for the data types. Sequence of characters. You can imagine it as a words, maybe, right? That can have all symbols on your keyboard, okay? So what is important here? We have like we have four string operation here. Sorry for the thing, but first we have two string concatenation. Okay, so you can use this. Maybe we only see this on numeric values, but you can use it on string values, okay, like this. It will concatenate it and it will become one. So, for example, hello plus word will become hello word in one string. Okay, so that's what is important. And for the length of the string, you can use len function. Okay, so len function, as you can see here, hello, len hello equals to 5 because it has 5 characters in your string. It has 5, okay? This is important. And the next one, we have taking a character from a position, count from 0. So what this actually is. So if we have this, okay, my name, you will take always count from 0. If you want to take here the zero letters, okay, so you count 0, 1, 2, 3, 4. It's on index 4 if you want to get the O letters, okay. It will go from, if you write this, it will be Pharaon 4, okay, like that. Why this is important, you will learn this on arrays next, but for the basic concept, we saw it as a string operation. And with this concept, we can move on to the next operation. It's a substring operation, where you want to take the substring. What is substring? Substring is a sequence of characters that you can take from the parent string. So, example, if we want to take the L here, we will take it 1, 2, 4. What is the formula for this? It will be string, string. You can be any string, and the start point is the start index to not last, n, sorry, n index plus 1. Okay. So if we want to take L from this string, you will count it 0, 1, 2, 3, 4. Because this is the start we want to get, we will use 1, 2. We want to take ELL. So this will be, the index will be 3 plus 1. So it will be 1, 2, 4. That's for string data types. Okay. That's for basic data types. And now we go to repetition. What is repetition? Simply, maybe we familiar it with loops. We're gonna move on to the what is the requirement for of good repetition. It's not a good repetition, but it's a working repetition. There is no such thing as good repetition, but if you didn't do this, the algorithm won't work. So it's not a loop at the end of the day. So it must stop eventually. So if your loops doesn't stop, it's wrong. It's not the right algorithm. So, and what I want to point is the third point here. Maybe people just not take this seriously, but programmer must know whether his repetition instruction will stop or run indefinitely when before the program is executed. So we as a programmer, we usually do like write the code, let the computers take all the job. But we actually needs to know how to make a good loops, okay? It will take from point 1 and point 2, like that. That's for repetition. And now we have repetition structures. We divide it like this, okay? I like to have a condition and by iteration. So if you familiar with this on the left one, it's a for loop, actually. This one is while loop, and this one is repeat until, okay? Let's dive one by one. For loops based on numbers of iterations. So if we already know how many iteration we will do for some action, some algorithm, we use for loops. Maybe we want to do something 5 times, use based on number of iteration, use for loops. But in some condition, we didn't know about what is the how many iteration we do, okay? We use the condition based on condition. So here it's while this true, you will do the action. Okay. So what is make the difference between while loops and repeat until? Repeat is you do this until it false. So if you want to change your code from while loop to repeat until loops, the tips is if this true, eh, sorry. If we name this as condition one, okay, on here, on repeat until algorithm, it's negation, it's a not condition one, condition one. Okay, that's how you translate your while to repeat until code. We can see the illustration if you guys understand this. I like to say it like while the true condition, you do the action and repeat until the condition is false, until the condition that you didn't want to happen, actually. That's how I understand repetition, and I hope you guys understand loops by that. And that's for our loops. And the next time we're gonna learn is branching. Maybe we familiar with if condition, okay? If, as if, and else. It's a branching, okay? Another condition. It's same, it's evaluates to true or false. The condition only have two values, okay, Boolean values, which is true or false. And what is important in branching? In many cases, and I see this a lot happen. You guys think every if always need else or always need else if no. The only thing that is important is for every if, there is always an and if. Okay, so let's see this by the code. Common mistake people do in this branching thing. People think that for every if, we need else if, and we need else. You didn't need to do. So common mistake here, let me demo to you, okay? Common mistake is, in this algorithm, I want to add +1 if the number is more or equals to 100, okay? Some of you guys do this, and even though this code is working, but it's 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 not good to see this. You didn't need to use this. If this, you do else. Else here, nothing happened, okay? So when you get this condition, don't use else, just use the if. This is the right condition for this algorithm, okay? So let me demo this code. Just so you know that this code is right. So if I have a number no, we use 100. So this condition will be true, right? It will do this action, okay? So, okay, it's worked. 1 has been added to X, 101. But if you guys have 90, do we need to do something with this algorithm? Do we need something to 90? Of course not. You get 90. You didn't need to do else blah blah. This is the code you will working for. And that's for branching. Okay. I hope you guys understand it. For every if, there's always an if. Don't forget about that. And I think that's all for this ALPRO1 review, right? Okay. The end of the slide. I don't know what is obrigado means, but that's what the slide says. And we'll see you again in the next videos.